So let's talk volume by slicing. So I'm going to just do two examples. So I'll just jump right into them. So the first one is going to be a square of side length 6 lies in a plane perpendicular to a line L. So one vertex of the square lies on L, and as the square moves a distance of 9 units along L, the square turns one revolution about L to generate a corkscrew-shaped column with square cross sections. So the question is, what is the volume? Okay, so like you might think at first like, oh gosh, I can't like visualize what this looks like. So the whole idea behind this is that we're doing volume by cross sections. So it's true, like what we're doing really is, right, we're taking this square and we're like rotating it along a line that's like units of length 9. So it's getting rotated all the way down this line. So it's going to be, yeah, this like corkscrew looking thing. But the thing is, actually for this one, like this is enough to really figure out everything that we need to know. So this has sides 6 and 6. So remember, at the end of the day, like what are we doing here? We are integrating from a starting point to an ending point. And the whole thing with this is you just have to know what is the area of the cross sections so that you can integrate. So this is why I say actually like this is one where as long as you know what the cross sections look like, you're good to go, because we can totally figure out the area of the cross sections, right? In this case, the area of the cross sections, they are just this boring square with sides 6. So my area is actually just 6 times 6. So my area is 36, okay? So that is what we are integrating. And then the other thing is like, okay, so where's our starting and ending point? Well, we're going a distance of 9 units along some line L, perpendicular to some line L. Even my picture is not that great. But like, so you can kind of just imagine this, but we're going from a starting point, the starting point will be 0, and then we go that distance of 9. So this is just set up from 0 to 9. So I'm just going to use 36 dx, and so there you go. And so then to integrate this, of course, this is just 36x, and then I just plug in my limits of integration. So this really comes out to 36 times 9. So this is 324 units cubed, whatever those units are, that would be the volume. So that one actually isn't so bad, just because like the nice thing is that we're using cross sections, and so we know exactly what it is that we're looking at. So the other example that I have is a tetrahedron, which is 3 triangles, or 4 triangles, I guess, all connected together to make this like 3D shape. So we want to find the volume of this. So once again, we're going to use cross sections for this. This one is hard. This one broke my brain a little bit. I had to think about it for a bit. Okay, so first of all, we have to think about like how do our cross sections like work, I guess. So in my case, what I'm going to do is, so I'm just going to think about, so a triangle that, like if I take a slice right here, so I have this triangle slice in here, okay? So obviously this is a triangle. Of course, I'm still just trying to integrate this situation here. So, okay, I totally know the area of a triangle, right? So the area of the triangle is going to be 1/2 base times height. So the issue is, the thing that like I was kind of breaking my brain on this with, is that it's like, okay, so what is the base and height though? Because if you think about it, here's my height. It's changing as we move along the tetrahedron, as is my base. So here's my base, right? It's right here, also changing. So I am going to orient my triangle going this way. So at least I know, so I'm going to go from, we'll call this our zeroing point, all the way back here. So from 0 to here, that's what we're going to integrate across. So I'm going to integrate from 0 to 10 of whatever this 1/2 base times height is. But I want to get everything in terms of x. Okay, so a few things that I think are helpful with this. First of all, I think it's good to label these points. So, but okay, it is good to label the points, but the problem is that we have 3 axes. So I have an x, y, and a z axis. So it's actually a little, we have to, before I label them, let's talk about a game plan here. So I need to figure out how this base is changing. So really this, let's say that this is like my zeroing side, okay? So really I'm measuring from here to out here. So if I'm just measuring from here to here, this base is determined by this line, right? So whatever this line is, whatever the value of this line is, that is going to be my base. So let's start there. So let's see, I'm going to get rid of this initial triangle. Let's just figure out how the heck, let's see, I'll do it this color. How the heck do I figure out this height? Well, this is ultimately just a line, right? And so I can figure out just the equation of a line. So I just want to like orient myself. So for this set of directions, so I am going to call this point for this situation. Let's see, I'll do it all in pink just so that we remember it in this situation. Let's call this 0, 8, and let's call this 10, 0. So these are sitting on two different axes. Now you might be saying, oh, but what if like the x versus the y axis? So I have compressed this down to 2 dimensions. So I can just then arbitrarily call this 10, 0 and 0, 8. So that's what indicates that they're just on 2 different axes, okay? And that's good enough. So using this, I need to find the line between 0, 8 and 10, 0, which we can totes do. So the slope, if I just use the slope formula, so this will be 8 over negative 10, right? So I take y1 minus y2 over x2 minus x2. So it's 8 over 10. So this equals ultimately negative 4 over 5. So then I've got my slope. I can take either point. I will take this point here. So this will become y minus 8 equals negative 4 over 5 times x minus 0. So this is y minus 8 equals negative 4 over 5x. So this equation is y equals negative 4 over 5x plus 8. Okay, so let's write that down. So y equals, let's see, actually that's for my base. So maybe I'll note that here. My base is negative 4, see I wrote negative 4 over 8. Sorry, I meant this to be negative 4 over 5. Negative 4 over 5x plus 8. Okay, so there's my base. So let me clear some space. So now that I have gone through and I figured out my base, so this side here is what's dictating height. So now we're going to do that. So I want to use a similar coordinate system. So in this case now I'm just using this axis and this axis. So this will continue to still be 10, 0, and now this side I'm going to view as 0, 6. So again, I can write these as 2 dimensions because I am just viewing this particular triangle, so I am only interested in these 2 dimensions. And then I'm going to do the exact same thing. So I've got the points 0, 6 and 10, 0. So in this case, my slope is going to be 6 over negative 10, so that's negative 3 over 5. And then I can do the same thing where I take y minus 6 equals negative 3 over 5 x minus 0. So ultimately I get x equals negative 3 over 5x plus 6. So this is my height. So my height now is negative 3 over 5x plus 6. Okay, so let me clear some space again. So one question now that we just want to confirm is, so is this x the same for both equations, or did I accidentally make like a different x? So here's the thing. If I now draw, so again, think about one of my slices here. So I hope you can still see or make this out with these different colors. Maybe I'll see if I can get rid of these other lines here. Yeah, okay, there. So, okay, so think about what this triangle looks like. So here's my height, here's my diagonal, and then here's my base. Okay, so this is what my slices look like. So this height, right, and this base, this is actually talking about that same moment of x as we move from here to here. So as I move down this 0 to 10 line, well, wherever I am in that, it's going to be the same value for both of these, right? So this is indeed correct. We're all good here. And so now I'm really ready to like keep moving with this. So this one I think was pretty hard to wrap your head around, like how to set up those equations. You know, it's one of those things, of course, once you see it, then I think a lot of times it makes a lot more sense, but it took me a second to kind of wrap my head around like, how am I going to figure those out? And the key, right, is you have to compress everything down into 2 dimensions. So here's what I've got. So let me make some space now. Okay, so let's see, I'll bring the 1/2 out for right now. So let's see, we need to FOIL this. So this will be negative 12 over 25x squared. And then let's see, we'll have minus 24 over 5x. Oh, again, minus 24 over 5x. and then plus 48. So let's see. This is going to be minus 48 over, forgot the x squared. Sometimes half the battle is just rewriting the previous step down properly. Okay, so now we can integrate this. So fun. So let's see. So this is 12. Let's see. Oh, wait, we're dividing by 3. So this really becomes 4 over 25x cubed, 24 over 5x squared, plus 48x. So this goes from 0 to 10. So when I plug in my limits of integration, I get 1/2 times 160, and so then that just becomes 80. And so there's our volume, 80 units cubed. So that was a toughie. All right, so I'm going to leave it at that. Hopefully that kind of gives you a better idea of some of the creativity that you do or don't need when these problems get kind of weird. If you found this helpful, I'd love it if you would hit that like button or maybe a comment or hit the subscribe button. That'd be real cool. Otherwise, I'm going to leave it at that. I'll talk to you guys later. Peace.